As your application users grow, so do the resources required to keep these applications up and running. And this is where application scalability comes in as a solution that helps you strike a balance between the number of users that keeps growing to access your application and the resources required to actually keep these applications up and running. Hello there, welcome to this Vultr Tech Talk. My name is Humphrey Paire and I am at Vultr here at Vultr. In today's Tech Talk, join me as we discuss application scalability using Vultr Load Balancer with an end goal of achieving secure and efficient application delivery. And to begin with, what's application scalability anyway? Application scalability is a solution that enables applications to handle increased user requests without affecting the general application performance. Application scalability improves the general application performance in the long run by striking a balance between the growing number of user requests and the resources required to keep this application up and running. It includes vertical and horizontal scaling, in which vertical scaling focuses on increasing the available resources to meet the growing number of user needs, while horizontal scaling is a form of replicating multiple resources to actually accommodate the growing number of user needs and ensure that the application performance improves over time while accommodating the increased number of users and traffic to your applications. And one of the clear implementations of horizontal scaling is the Vultr Load Balancer. Vultr Load Balancer is a managed service that distributes and directs traffic to linked instances. It manages traffic using a unique endpoint, which enables you to set up a single domain record, forward traffic to multiple instances. And from a security point of view, a Vultr Load Balancer ensures that common attacks fail, since multiple instances act as one to serve your application. And to ensure that your application performance stays intact, the Vultr Load Balancer has a health check feature which ensures that your instances and hosted applications are healthy before forwarding any traffic to them, to ensure that your users do not experience any downtime or potential errors while accessing your applications. And among the notable Vultr Load Balancer features, it supports efficient load balancing algorithms, which include the round-robin and list connection mechanisms. With round-robin, each instance linked to the load balancer receives an equal share of the traffic, while list connections ensures that a server with the list connections can actually process requests at a time. And on the other hand, the load balancer supports automatic health checks on particular endpoints to ensure that your servers are healthy before actually forwarding any traffic. To ensure that all connections to your endpoint are actually secure, the load balancer supports automatic SSL to ensure that all traffic to your linked domains is served over HTTPS with secure SSL certificates. And among the notable protocols supported by the load balancer, HTTP, HTTPS, HTTP version 2 and HTTP version 3 are all supported protocols to ensure that your applications can actually serve traffic using modern technologies. And to ensure that all traffic to your load balancer is secure, the Vultr Load Balancer integrates with Vultr Firewall, which filters network traffic and ensure that only specific allowed sources can send requests to your load balancer, which in turn forwards the traffic to your linked instances. And so, how exactly does the Vultr Load Balancer work? In a normal situation, users across the internet access your application using a single instance. And in case of traffic spikes, all these users actually grow in number, the server will actually start returning critical errors such as a 503 service unavailable error and start throwing warnings in your server logs, and some processes may actually stop in the long run. And to address this, the load balancer supports multiple users, and each time users actually come in to access your application, instead of reaching your server directly, they reach the Vultr Load Balancer endpoint, and the Vultr Load Balancer will forward this traffic to any of the available instances depending on the load balancing algorithms you actually set. So, based on this background, let me take you right into a demo where we shall use the Vultr Load Balancer to actually forward traffic to multiple instances that will be running the same application and ensure that users can actually access our applications without really identifying which server is actually serving the request at a particular time. And so, without any further ado, let's get right into this demo process. And so, to actually get started with that demo process, I have 3 existing servers in my Vultr account. So all of these servers, one key identifier or one key thing that matches in between them is the location. all these servers are in the Paris, France location. So this ensures that we can actually use a load balancer in this particular location in order to route traffic to all these servers. So now that we have some existing servers to work with, let's go ahead and actually deploy a Vultr Load Balancer. And to do so, we simply go to Load Balancers on this main navigation menu for the products and click Load Balancers. In order to deploy a load balancer, you simply have to click Add Load Balancer and select your target load balancer location. For instance, we can select Paris, France. Now in the label here, let's give it a simple label such as Test LB. And in order to have this Vultr Load Balancer actually up and running, we need some forwarding rules which specify how traffic from the load balancer is actually forwarded to the linked instances. And in this particular case, you can see that we have the HTTP protocol selected for both the load balancer and the instance side. So this means on the load balancer port 80, it will be redirected to the instance port 80. And let's keep the VPC network public. And since we are not targeting to actually apply any Vultr firewall rules, let's keep this empty as well. And let's keep the default path for healthy checks in order to be notified in case there is any failure that the load balancer cannot actually load the main endpoint here. So now let's click Add Load Balancer to go ahead and deploy this load balancer instance. And now as the process runs, I have this existing load balancer we can go ahead and use. It includes the same rules as we have deployed. And just to confirm, we have no linked instances to this load balancer. And the default algorithm is round robin as we did set. And the default forwarding rule is HTTP for both load balancer and the instance. So let's go ahead back to the overview tab and link some instances. So just click Add Instance. And right here in this dialog, let's select our target instance. You can say I have server 1, server 2, server 3. So let me select server 1 and attach it. And now that we have added server 1, let's go ahead and add server 2, which is server 2 pre-selected here, and click Attach Instance to add it. And now that we have server 1 and server 2 added, let's also add our server 3 in order to have a variety of options we can work with. And now let's click Attach Instance yet again. So, as you can see in this particular load balancer output now, we have a working load balancer and we have 3 attached instances. So let's go right into my SSH session where I have established some sessions for these particular instances. If you see in my first terminal session here, we have server 2, and server 2 is a Rocky Linux instance, server 1 an Ubuntu 24.04 instance, and server 3 is a Debian 12 instance. So right within this SSH session, let's actually go ahead and run similar applications on each of these servers. Now for server 2, which is a Rocky Linux server, let's go ahead and install the Apache web server. Let's go ahead and install the Nginx web server on server 1. And on server 3, let's do the same on server 1. We have installed the HTTP package here, which is for Apache on this particular server. We have installed Nginx here and we have installed Nginx here. So let's go ahead and start each of these web servers on each of these servers. So let's go ahead and start Nginx again on server 3. So you can see that we have Apache running on Rocky Linux. We have Nginx running on server 1, which is Ubuntu 24.04, and we have Nginx running yet again on Debian 12. And each of these web servers normally serves web applications from the var.html directory. So let's enter that directory right here. So if we open the index.html and let's paste these values that we actually have here for the application logic, let's open the HTML tag and save this file. So as you can see in here, this simple HTML application outputs a greetings from Vultr heading and actually adds another heading which is hello from server 3 when loaded. So let's exit this and let's do the same on server 1. Let's go into the var.dub directory. So let's do the same on server 3. Now this is server 3, yes. Let's modify server 1 and verify that it's indeed server 1. Let's just change the message to server 1. Change the server 2. So now that we have some application logic we can apply here, let's just go ahead and restart each of the web servers. So now that we have restarted all web servers, our applications should be able to load correctly. So let's go back into the web browser and see if we have a fine result in here. So if we go into the web browser here and refresh this page, you will see that we have a simple message, which is greetings from Vultr and hello from server 3. And if we refresh again, we have hello from server 1. Let's see if we have hello from server 2, which is the Apache server. So just to verify that, let's just right click and see if the result is the same. Let's magnify this page a little bit, and let's just do this in an interactive way. So if we click refresh, you'll see we have hello from server 3. If we refresh again, we have hello from server 1. And if we refresh again, we have hello from server 2. So this means our load balancer is working correctly and forwarding traffic to each of these instances. And so, Vultr Load Balancer, as we have explored in our demo, is an amazing service you can actually apply to ensure that you can implement application scalability for your existing applications without actually affecting your general application performance. In production environments, say you have a dynamic web application running a stack such as WordPress, you might have to attach all these instances to the same VPC 2.0 network and use additional storage mechanisms such as Vultr Object Storage to ensure that these servers have the same exact data at the same exact time. If a change is written on server 1, you must ensure that it's written on server 2 and server 3 in real time to ensure that users actually receive updated data without any delays or any update intervals that you may actually prefer. And so, just like that, we explored a basic implementation of Vultr Load Balancer in which you can actually use multiple instances to act as one using the Vultr Load Balancer. And so, if you did find this Vultr Load Balancer Tech Talk useful, I hope to see you in the next Vultr Tech Talk, which will focus on advanced techniques using automatic SSL certificates and global regions for Vultr Load Balancer. Once again, thank you for watching and see you in the next Vultr Tech Talk. Thank you for watching.